The diagram shows an electrical circuit with the values of its components. The cells have a negligible internal resistance. Show using Kirchhoff's laws that the current in the 6 ohm resistor is 1.5 amps. Calculate the potential difference between X and Y. The first step is we assume the direction of current at any part of this circuit. Let current to the left from the node X be to the right, and let it be I1. And all other currents will be dependent, and always we can imagine current as flow of water, and if water is in here, hence water must be out here. Let it be current I2. Currents after the node are different, so we should use another indices, and let it be I3 here. Hence I2 is in Y, because I2 is moving in clockwise direction, and I3 is in Y, and current I1 is in this direction because it is moving in clockwise direction. There is another possibility. For example, let current to the right from the X be in. Indices don't matter. Hence, this current must be out, and this current also must be out. Hence, I3 is in Y, I1 is from Y, and I2 is in Y. Or it may be that current in X be here. Hence, let it be I1, hence this must be out, this also must be out, and if we consider Y, it looks like I1 in this direction, I2 in this direction, and I3 in this direction. And the first Kirchhoff's law says that if we consider any node, the total current in is equal to the total current out, and for the node X, we can see the total current in, it's only I1, is equal to the total current out, is I2 plus I3. And if we consider the node Y, the total current in, it's I2 plus I3, is equal to the total current out, it's I1. And we can see that these two equations are identical, so it's dependent equation and we don't need it. And the second Kirchhoff's law says that for any complete, it means connected circuit, the sum of current multiplied by resistance is equal to the sum of EMFs. And let's consider a complete circuit, for example, X, A, B, Y. X, A, B, Y. We need to choose some direction, clockwise or anti-clockwise, as positive. Let clockwise direction be positive. So we are moving from X to A, to B, to Y, and again to X. And if we can see that current through 2 ohm resistor is I2 and it is in clockwise direction, so it should be considered as positive, so we write 2I2. We are going and meet another resistor or some component which has a resistance. It also in general may be a cell. If it has internal resistance, we also should consider current multiplied by resistance, but this cell has a negligible internal resistance, so IR for it is equal to 0. And we can see that I3 is in anti-clockwise direction, so it must be minus 6 multiplied by I3 is equal to, consider EMFs, and we can see that there is only one cell, this one, and we know that here is positive terminal, here is negative terminal, and current provided by this cell is in this direction, and it is in opposite direction to the direction which is chosen as positive. It is chosen that clockwise direction is positive, but current provided by this cell is in anti-clockwise direction, so we should write negative. It's negative 12. And there are no more cells. Let's consider, for example, X, Y, CD. X, Y, C, D. So we are moving from X to Y to C to D and to X. And let's choose also some direction as positive. Let it be again clockwise direction as positive. So we can see current I3 is in clockwise direction, so it's positive, and we write 6 I3. And the next component is 3 ohm resistor, so its current is I1 and also in positive direction, so it's plus 3 I1 is equal to plus is here, minus is here, so current provided by this cell is in clockwise direction, so it's positive, plus 9. And we can see that we have 3 unknown variables, I1, I2, I3, or 3 unknown values, and there are 3 equations. Hence, we can solve these simultaneous equations and find I1, I2, and I3. And it's not needed, but let's consider A, B, C, D, and let's see what can we get. So we consider A, B, C, D, and again A. So we are moving in this direction. So we can see 3 ohm resistor. So it's plus because I1 is in clockwise direction, so it becomes 3 I1 plus 2 I2 is equal to negative 12 plus 9. And you can see that it's dependent equation. If you add both sides of these two equations, you get this equation. And how to solve the obtained simultaneous equations to find currents? We can see that we can solve, for example, for I2 here in terms of I1, so 2I2 is 6I3 minus 12, so I2 is 3I3 minus 6, and we can substitute into the first and get that I1 is I2, which is 3I3 minus 6, plus I3, which is 4I3 minus 6, and we can consider this equation and this one, so together with 6I3 plus 3I1 is 9, and we can see that I1 becomes from here divide by 3, so it's 3 minus 2i3, and we can equate this and this because it's i1 and it's also i1, so 4i3 minus 6 is 3 minus 2i3, so 6i3 is 9, hence i3 is 1.5 amps, and it's very important to get that it's positive value, hence chosen direction, because it's from assumption, hence this direction is correct. And if you get, for example, if you get negative 1.5 amps, it means that actual direction of i3 is in opposite direction, so it would be i3 to be here, hence i2 should be in this direction and i1 in this direction. And the next question, potential difference between x and y. What is potential difference? It's actually the same as also voltage, and potential difference, it's current multiplied by the resistance. Hence, if it's between x and y, we can see that current is i3 and resistance, the only component is 6 ohm resistor, so it's i3, it's 1.5 multiplied by 6, it's 9 volts. And that's all for this question.